Let's solve another easier problem. So this one involves a single elimination tennis tournament where there are 5,763 players. In each round of the tournament, players are paired up and the loser is eliminated. Whenever there are an odd number of players, then one player is chosen to advance to the next round without having to play. This is called a bye. How many games will be played when the tournament is over and we've got just one player left, the champion? Well, if we have one player sit out the first round, then take the remaining 5,762 players, pair them up, and there'll be 2,881 games. But this could get ugly fast. We have to keep track of the number of games. We have to make sure that when players sit out, we get them back in the next round. We could get there, but it wouldn't be pretty. So let's do an easier related problem. What if there were 3 players in the tournament, A, B, and C? A plays B while C gets a bye, and then the winner of the A-B match plays C to determine the tournament winner. 2 games total. Well, that was pretty easy. What if there were 4 players, A, B, C, and D? Well, then in round 1 we'd have A versus B, and we'll say that B won, and C versus D, and we'll say that C won. Then in round 2 we'll have B versus C, we'll say B was the winner. But notice we needed a total of 3 games. A versus B, C versus D, and B versus C. If you do this once or twice more, you suddenly realize the number of games is 1 less than the number of players. And that makes a lot of sense. If we have 5,763 players, and then 5,762 of them have to be eliminated to determine a champion, and so it takes 5,762 games to eliminate all but one of the players. If we had used our original approach and just tried to break down that 5,762, pairing them up round after round after round, if we were very careful, we would have gotten to that same number, 5,762, but we might not have realized why that makes so much sense. You have to eliminate all the players except one. So this is another example of a problem that can be solved by looking at easier related problems. And of course, it's also something of a pattern problem.